Okay, this slide will find price elasticity of demand, but maybe we use a graph. So a graphical interpretation of price elasticity of demand, because still in demand side. Yes, in demand side, not yet the other side. Previously, we have formulated the price elasticity of demand by this one. This one. This one, percentage change of quantity demanded. This one, percentage change of price. Okay, it depends on percentage change code X, right? X. So again, how to find percentage change? That means the change of quantity demanded divided by quantity of demand. 5% change of price. Change is price divided by the price. What does it mean? Change that means quantity demanded ending minus quantity demanded beginning divided by Q. Same thing, change in price ending minus price beginning and divided by price. Okay, so look at this one. This is Q ending together consistent with P ending minus Q beginning consistent with P beginning. Okay, how about Q here? How about P here? It depends on question. If the question asking at original price, so we divide it by beginning Q beginning P at original price. But the question not asking not at original price. It's saying asking at new price or ending price. New price or ending price, it should be ending. Okay. But the question asking not original price, not at new price or ending price, but middle price. If middle price, we also divide it by middle. Middle is M. How to find middle price? How to find middle price? If talking about price, middle price comes from ending price or beginning price plus together, both of them together, divided by 2. Ending price plus beginning price divided by 2, or beginning price plus ending price divided by 2, they are the same. If talking about middle quantity, yes, same thing. Ending quantity divided plus beginning quantity divided by 2, or beginning quantity plus ending quantity divided by 2. So this is middle. Okay, so this is the formula that we look at so far. But now, how about graphic? How about graphic? Will you use this formula? No. Why not? Because this formula is about change. Change. Graphics sometimes no change. It's asking only 1 point on the graph. If we asking about 1 point on the graph, there's no change. So we cannot use this one. If you cannot use this one, what will you do? What will we do? We use this one. For example, epsilon at point A, PA, QA. Still have change, but we don't say change here. Okay, so previously we have formulated the price elasticity demand like this one, epsilon equal to percentage change of quantity demanded divided by percentage change of price. One attractive feature of this formula is that it has a straightforward graphical interpretation. Thus, if we want to calculate the price elasticity demand at point A, like I say here, on demand curve shown in figure 4.3, we can begin by rewriting this formula. Rewriting the right hand side. Rewriting only the right hand side. Rewriting the right hand side. Okay, so this is the same formula as we have in the earlier. So we rewrite. This is one fraction, second fraction. The first fraction, second fraction. Based on mathematical formula, the first fraction divided by the second fraction, we take the first fraction multiplied by inverse of second fraction. Inverse of second fraction. That's why this is a fraction divided by fraction. We keep the first fraction the same thing, but multiplied by inverse. Okay, inverse. So we got that one. We take a chain on a chain in one side and no chain in one side. So I just I change the order, or I change the location. Okay, like this one. If we're talking about epsilon at point A, finally we get PA divided by QA multiplied by percentage. Sorry, not percentage. The chain Q divided by chain P. So what is chain Q? What is chain P? Remember the slope? Remember slope from previous chapters? I think appendix chapter 1 also talking about slope. Okay. Slope for a straight line. Slope for a straight line. Remember that part 1? I think some of you still remember. If you are not, or if you don't remember, you can go to see that movie again. Slope is based on appendix chapter 1. Rise over run. What is rise? The chain vertical. Actually at that time chain Y, but now we don't have Y, but we have P. We have P. Run, the chain in horizontal. Horizontal at that time we call X, but now we don't have X, we have Q. Okay? We have Q. But this is not slope, 1 over slope. If I take 1 over, this is a first fraction. This is first fraction, 1 over 1 divided by second fraction. That's why 1 over slope, maybe I not write too long, just S, equal to 1 over 1 multiplied by inverse again, chain Q over chain P. So 1 over 1 is 1. 1 multiplied by something is something. That's why 1 over slope is chain Q over chain P. What is chain Q over chain P? Chain Q over chain P here. Okay, that's why epsilon at point A equal to PA divided by QA multiplied by 1 over slope of point A. But in the, on a straight line or for straight line, the slope of any point is the same thing the slope of the line. Okay, the slope of any point is the same thing as the slope of the line. How to find slope of the line? To find slope equation, this is a slope equation. Okay, so if you not understand, or if you don't understand, if you are not clear, okay, you can ask me. But again, I just remind you, you can go to see appendix chapter 1, the slope of a line. The slope of a line is 1. We get the change in vertical that we call rise, divided by the change in horizontal that we call run. Okay, but we want to get this rise over run. It should be the change in P over change in Q, but our formula not change P over Q, but change Q over P. That's why in order to have the same picture like this one, we need to convert this one into the change Q over P, change Q over change P. That's why we need to make an inverse, okay, like this one. So again, based on the formula, I can see that the epsilon at point A equal to PA divided by QA, 1 over slope at point A. But the slope at point A normally equal to slope of the line, or the line. The line in over here is a demand curve. That's why I can say the slope of, slope of demand curve. Okay, so the price elasticity of demand at point A is epsilon A QA divided by PA divided by QA and multiplied by 1 over slope A. But 1 over slope A equal to slope line. So based on go back to the our, based on what? Based on figure 4.3. It should be this here, figure 4.3. Is it that one? Figure 4.3. Oh, this is figure 4.4. You can go to see figure 4.3. We don't have 4.3 here. This is 4.4. Is it 4.3 here? Let's see. 8.3. Okay, 8.3. This is 4.3. 8.3. So we can see 8.3 here. P equal to 8. Q will be 3. P equal to 8, Q will be 3. These are the other question on this page. Okay. So if at point A figure, based on the figure, at point A, P equal to 8, Q equal to 3. So the change in P, how can we get change in P? You can compare from this one to the other one. Okay. Get 4, or to get 4, how to get 4, change in P, how to get 4, maybe I compare to the other. Yes, you can compare to the other one. Okay, based on this one, how to get 4, maybe I compare, or I take, not point B, I take maybe this one. Okay, I take maybe point, let's say, I take maybe point M, for example, this one M. Okay, so I will want to find change P here, change Q here. So change ending minus beginning. Maybe I can take ending A in terms of P, A minus M. A minus M, it means 8 minus 4. Okay, and the other one I'm talking about Q, A minus m. A is 3 minus m is 4. That's why this is 4, this is minus 1. Okay, 4 minus 1. But in this case we don't have, actually we don't have we should be have minus 1 here. This is minus 1. Okay, or in this case maybe this, you can take any time. You can take this minus 4 and this is plus 1. If you take m minus a, not a minus m. Okay, however the slope is negative slope. The slope is negative slope. So in this case, if I want to find epsilon a equal to PA divided by QA multiplied by 1 over slope. What is slope? What is slope? Slope is 4. Why is it 4? Because slope equal to change P over change Q. What is change P? 4. What is change Q? Minus 1. That's why minus 4. Here. This is slope. So this result. How to interpret this result? How to interpret this result? In order to interpret this result, you need to go back to this one. But this one maybe I'm not saying in the pork market, but I say on the graph at point A, on the graph 4.3 at point A, because we're talking about graph. Okay, in order to interpret this result, minus 0.67 or minus 0.67, I will use this style to interpret. But I'm not saying about in the pork market, because this is interpretation for our example here, pork market. But in our case now, we are not in the pork market. We are on the graph 4.3 point A. That's why in the graph at point A, when the price something like this, okay, when the price of what product we don't know, we just say one product, because I don't see what product that on the graph. That's why you can say when the price of one product increase or decrease, because we don't have we don't see increase or decrease, you can substitute that increase or change. Increase, if you're talking about this increase, so quantity must be decrease. If talking about decrease, quantity must be increase. But in general, if you don't know increase or decrease, maybe it's better not to say increase or decrease. Maybe I can say that in figure 4.3 at point A, when the price of one product change, I use change. Oh, sorry, not change, that's one. However, change by 1%. Change by 1%. The quantity demanded for that product will negatively change. Negative change or negatively change by 0.67%. Why negatively change? Because the result is negative. The result is negative. Okay, the result is negative. That's why negatively change by 0.67. You can ask why this information, this example, we don't say negatively change. Yes, we don't say negatively change because this example tells you exactly false and increase. Because negative sign that I mentioned in this for previous video, negative sign here will go to these words. But in this case, you change, I don't know which change. That's why negatively change. Okay, negatively change, that means change the opposite from the previous one. If the previous one change by go up, negatively change for Q will be go down. Or if previous one it means P If P change by go down, negatively change of Q will be go up. Okay, because we don't know. That's why if you will say change, we don't know change the same direction or change different direction. But if you know exactly here decrease and increase, they change but change different direction. That's why this is negative pictures. Okay. Okay. This is the other side. What is the price elasticity of demand at P equal to 4? P equal to 4, demand curve on figure 4.4, page 103, but I'm not sure of 103. This is old textbook. A new textbook maybe the other page. You can check from your own textbook. Just go to figure 4.4. Don't go to page. Maybe page change. Okay. For example, the other one at mid price. At mid price, what is the price elasticity of demand from A to from B to A? At mid price or middle price. Remember, I say M, not end in the beginning, but I say M, middle price. What is the price elasticity from B to A? From B to A, how many points? Point B, point A. B to A is about change. That's why even you have graph, but in this question may not the same this question, because this question asking only 1 point. That's why on the graph, if they asking one epsilon of 1 point, for example point A, you need to use the formula of the graph for 1 point. PA over QA multiplied by 1 over slope A. But in this case, they ask from B to A. You don't need to find this one. So what do you find? What can we find? What can you find? By using this formula. Because this formula you can find a change. You can find a change. Okay, you can find a change. That's why don't use this one. Okay, don't use this one. Use the change. But Q, how about Q here? Q here, beginning Q or ending Q? No, it's about Q and P here is about middle Q, middle P. Okay, so now you go to in your textbook, you go to figure 4.4 and find the price elasticity of demand at P Q to 4. And based on this one, middle price, what is price elasticity of demand from B to A? From B to A. So in this slide, you have 2 questions, 2 answers. Okay. So I'm waiting to see your answer. Answer with explanation or answer with interpretation. Okay. Now I have 2 curves on the same graph. Let's say 2 buyers. Buyer 1, buyer 2. When there are 2 demand curves crossing, you can see crossing with this point. When 2 demand curve crossing, P over Q is the same for both curves. Let's say I see point X. This is point X. Crossing at point X. At point X, P over Q at the same. For D1, P over Q, it means that D1, if we're talking about P over Q at point X, for D1, Px over Qx is the same as Px over Qx of D2. Why? Because they are the same. Okay, the same curve. Not the same curve, the same point. That's why x on D1 is this side, x on D2 is this side. But because of this one on the same location here, that's why they are the same. However, 1 over slope of D1 for x is smaller absolute amount for steeper curve. Which one steeper? D1 steeper. That's why 1 over slope of D1 smaller. What is it smaller? Smaller. 1 over slope of D1, this is D2. Okay? In terms of point, in terms of P over Q, they are the same, D1, D2. But 1 over slope, the curve that's steeper, 1 over slope smaller than flatter. So D2 flatter, D1 steeper. At common point, let's say point X, at common point at the same point, D1 is less price elasticity because steeper. Okay, because steeper that means smaller slope. But D2 is more price elasticity because flatter. So in this case, if you have 2 demand curve or 3 demand curve, if you have many demand curves, that those demand curves intersect at one point, and we want to find elasticity at this point. No the other point, only this point. Only point 8 here. Okay? If you have 3 demand curve, for example, 3 demand curve, 3 demand curve, okay, 4 demand curve, 1, 2, 3, 4. I have 4 demand curve, and this point is point X. We want to find price elasticity demand at point X. That's why this one most elasticity, this one is very steep, this is very inelasticity. Okay, why? Because we're talking about at the same point, at the point X, P over Q or X between D1, D2, D3, D4 the same, but in terms of slope they are not the same. 1 over slope not the same. Okay, so in terms of P over Q for X is the same for all curve, but in terms of slope, the flatter tend to be bigger, the steeper tend to be smaller. Okay, smaller that means less elastic or inelastic. Steep, flatter it means more elastic or elastic. Okay, this is like practice. For demand curve D1 and D2 shown in figure 4.5, calculate the price elasticity demand at P equal to 4. P equal to 4 is point A. That means point A. When what is the price elasticity of demand for D1? For D1, when the price is 8, this point I can say you can label any letter. I say M. What is the price elasticity demand for D2 when P equal to 1? P equal to 1 is this one. This one. I can say N. Okay, so this is the question. For you to practice. Yes, I will go there. Okay, go there. So this is for you to practice. You have 1 question, 2 question, 3 questions. So total 3 questions for you to find price elasticity. That means you need to find epsilon A. Epsilon based on my explanation I put but you can put C, D, E is it depends on you. But no, don't put D, because if you put D you will confuse with this one. You can put C, B, but I put M, N. So This is for you to practice. The slope of straight line demand curve is constant. That means the slope of straight line demand curve is constant, and also the same as the slope of any point on this demand curve. But the price quantity ratio is declined as the point move down along. Okay, talking about this one. Oh no, only to say the same number. Okay, the same. It should be the same curve. This is two curve. Okay, let's look at this one. Okay, look at this one. The slope of demand curve. The slope of D is demand curve here, or equal to the slope of A, equal to the slope of B, or the slope of anything, any point, like this point, this point, this point, this point. So along this demand curve, any point has the same slope as the curve, but any point don't have P over Q, the same thing as the other point. For example, P over Q for B and P over Q for A. Okay, but by taking this one, so P over Q for A, this one, P over Q for B, this one, P over Q for A. Which one is more bigger? When we move along down, here, so the P over Q that we move along becomes smaller. That means P over Q for B bigger than P over Q for A. When we move along down the demand curve, P over Q from one point to next become smaller. However, if we move along the demand curve but from bottom to up, it become bigger. Okay, but maybe don't let you confuse. Just say along downward. If we move along downward our demand curve, the upper point P over Q bigger than P over Q of this is Q A. Okay, the others. Okay, this is a condition that we need to look at. The elasticity of demand does decline steadily as we move downward along straight line. Decline, that means become what? Okay, become inelastic. So area that means any point on the curve but upper area of the curve, so price elasticity demand tend to be more elastic, but down here tend to be less elastic. How about the middle one? Middle one is unit elastic or constant elastic. That's why the elastic at middle point of the line will be equal to 1. The elastic above middle point is more than 1 elastic. The elastic below midpoint is less than 1, less than inelastic, like here. Okay, so if you have a demand curve like this one, you need to find the middle demand curve. At around the middle demand curve, epsilon equal to 1. Maybe you can ask me, oh, why is epsilon equal to 1? It should be absolute value epsilon. Okay, absolute value epsilon. At the middle point, absolute value epsilon equal to 1. Below that middle, absolute value epsilon less than 1, that means inelastic. But higher than middle point, absolute value epsilon is more than 1, that means elastic. Okay. We have special case. Some cases, not all, only some cases or few cases. Our demand curve is flat like this one, or a vertical like this one, or horizontal flat as one, or vertical flat as one. If we have demand curve horizontal flat like this one, epsilon is infinity. Infinity. We cannot limit. We cannot set what is it? A big, very very big. But I don't know. We cannot limit it. That's called infinity. Infinity. But if we have demand curve like a vertical set like this one, epsilon is always 0. Why is always 0? Because change in Q equal to 0. 0 divided by change in P. If change in P anything, is still 0. How about this one? Why is it infinite? Because change in P equal to 0. Okay, so everything change in Q divided by 0 is infinite. Infinite. Okay. Okay. I stop by that one and back to